Welcome to my sleep science channel. Tonight, settle into a quiet place. Relax your shoulders, close your eyes if you want to, and drift with me into the enormous darkness beyond Earth. Before we begin, take a gentle moment to like the video, subscribe to the channel, and tell me where you are watching from. Somewhere tonight, people are listening beneath city lights, beside rainy windows, inside quiet villages, on ships at sea, or under desert stars. And all across Earth, every listener is sharing the same invisible ocean of air. The question sounds simple at first. Are there other planets where we can breathe? But the deeper humanity looks into space, the stranger the answer becomes. Breathing is something so ordinary that most people almost never think about it. Every minute, your lungs quietly pull air into your body without asking permission. Oxygen slips into your blood, carbon dioxide slips back out, and your life continues without effort. Earth has wrapped this process around us since the beginning of human history. The atmosphere is so familiar that it feels permanent. Yet beyond this thin blanket of air lies a universe where breathing may be one of the rarest experiences imaginable. If you could rise slowly upward tonight, above your house, above your city, above the clouds themselves, you would eventually reach the edge of the atmosphere. Pilots call part of this region the stratosphere. Above that, the sky begins to darken into something almost black. And then, finally, space begins. No wind, no sound, no scent of rain or forests or oceans, just silence and vacuum stretching in every direction. Human beings were never designed for that environment. Without pressure, the fluids inside the body begin to behave dangerously. Without oxygen, consciousness fades in moments. Space is not merely empty. It is actively hostile to breathing creatures. Yet despite this, humans continue searching the skies for another world that feels even slightly like home. For thousands of years, ancient civilizations looked at the planets with curiosity and fear. Mars glowed red like an ember in the night. Venus shined brilliantly before sunrise. Jupiter moved slowly among the stars like a wandering lantern. Nobody knew these worlds were planets in the modern sense. They were mysteries, lights drifting across the heavens. Some cultures imagined gods living there. Others imagined spirits or celestial kingdoms. Almost nobody imagined that one day human beings would ask a practical question about them. Could we survive there? Could we stand beneath another sky and breathe naturally? The modern search began slowly. Telescopes improved. Mathematics improved. Eventually, humanity discovered that Earth was not the center of existence. Our planet became one small world, orbiting one ordinary star among billions. That realization changed everything. Suddenly, the possibility of other Earths no longer sounded impossible. If one breathing world existed, perhaps others existed too. Scientists eventually learned that breathing is not only about oxygen. Pressure matters. Temperature matters. Radiation matters. A planet could contain oxygen and still kill a human instantly. A planet could have water, but no stable atmosphere. It could have clouds made of acid, rain made of methane, or winds faster than sound. In the universe, the word habitable is far more complicated than comfortable. Even Earth itself is surprisingly delicate. If our atmosphere contained much less oxygen, large animals might never have evolved. If it contained far more oxygen, forests could ignite from lightning far more easily. If Earth moved slightly closer to the sun, oceans could slowly evaporate. Slightly farther away, much of the planet could freeze. Humanity exists within an extraordinarily narrow band of conditions. We breathe because Earth maintains a careful balance every second of every day. Tonight, somewhere above you, thousands of satellites are circling the planet. Astronauts float aboard orbiting stations surrounded by machinery that constantly recreates the conditions of Earth. Air Filters hum softly. Oxygen generators operate continuously. Carbon dioxide is removed from the cabin little by little. Even a few hundred kilometers above Earth, survival already depends entirely on technology. That reality quietly reminds us how precious our atmosphere truly is. And yet, despite all these difficulties, scientists continue discovering remarkable worlds. Some are frozen planets drifting around dim stars. Some are giant rocky worlds larger than Earth. Some may contain endless oceans beneath layers of ice. Others may possess atmospheres thick with unfamiliar gases. Every year, telescopes become more powerful. Every year, humanity learns more about distant skies. Somewhere out there may exist forests moving beneath alien winds. Somewhere there may be oceans reflecting unfamiliar stars. Somewhere clouds may drift across mountains untouched by any human eye. And on one of those distant worlds, perhaps the air is calm enough, rich enough, gentle enough for a human being to remove a helmet, inhale slowly, and survive. For now, however, every human breath still belongs to Earth. Every laugh, every conversation, every sleeping child, every whisper in the dark depends upon this fragile atmosphere surrounding a small blue world floating silently through space. And perhaps that is why the search for another breathable planet feels so emotional. Humanity is not only searching for survival. Humanity is searching for another place that feels alive in the same quiet way Earth does tonight. As the planet turns beneath the night sky, billions of breaths rise invisibly into the darkness together. And somewhere beyond that darkness, hidden among countless stars, another atmosphere may already be waiting. Most people rarely think about the air around them. It feels invisible, automatic, permanent. Yet the ability to breathe is the result of an astonishing chain of conditions that began billions of years ago. The air surrounding Earth is not random. It is the product of geology, chemistry, sunlight, oceans, microscopic organisms, forests, volcanoes, and time itself. To understand whether humanity can breathe on another planet, we first have to understand why breathing works here at all. At this very moment, your lungs are quietly expanding and relaxing over and over again. With each breath, oxygen enters through your nose or mouth, travels down branching airways, and reaches millions of tiny air sacs called alveoli. These structures are incredibly delicate. Their walls are thinner than paper. Tiny blood vessels press against them constantly, allowing oxygen to slip into the bloodstream while carbon dioxide leaves the body. Inside your blood are red blood cells carrying hemoglobin, a remarkable molecule built specifically to transport oxygen. Without oxygen, the cells of the human body cannot efficiently produce energy. The brain especially depends upon a constant oxygen supply. Even a few minutes without it causes permanent damage. Human beings are creatures built around oxygen from the deepest biological level upward. But oxygen alone is not enough. If you climbed high enough on Earth, you would eventually discover something dangerous. The atmosphere becomes thinner with altitude. There is still oxygen high above mountains, but there is less pressure pushing it into the lungs. Climbers on Mount Everest often describe confusion, exhaustion, and dizziness because their bodies struggle to absorb enough oxygen. Some require tanks of concentrated oxygen just to survive. This means that breathing depends not only on what the atmosphere contains, but also on how dense that atmosphere is. Imagine standing on another planet with an atmosphere containing the same percentage of oxygen as Earth, but with only a fraction of the pressure. Your lungs would still struggle. Breathing would feel shallow and ineffective. The human body evolved specifically for the atmospheric pressure near sea level on Earth. Our biology is quietly calibrated to this exact environment. Temperature matters too. Air behaves differently depending on heat and cold. Extremely cold worlds may freeze moisture inside airways. Extremely hot worlds could damage lung tissue with every breath. Even humidity affects survival. The human body constantly loses water while breathing, and dry environments can slowly dehydrate a person without them realizing it. Earth balances these conditions with remarkable precision. The atmosphere surrounding our planet is composed mostly of nitrogen, about 78%. Oxygen makes up roughly 21%. The remaining portion includes argon, carbon dioxide, and traces of other gases. That mixture may sound ordinary, but it is extraordinarily unusual when compared to the environment scientists observe elsewhere in the solar system. Mars has a very thin atmosphere made mostly of carbon dioxide. Venus has an atmosphere so thick and hot that lead could melt on its surface. The giant planets like Jupiter and Saturn contain hydrogen and helium instead of breathable air. Many moons have almost no atmosphere at all. Again and again, humanity discovers environments where breathing naturally is impossible. Long before humans existed, Earth itself was once unbreathable. Billions of years ago, the atmosphere contained very little oxygen. Volcanoes dominated the landscape. The skies may have looked hazy and orange. Oceans contained strange chemistry unfamiliar to modern life. Early microscopic organisms survived without oxygen entirely. Then something extraordinary happened. Tiny organisms in ancient oceans began using sunlight to produce energy through photosynthesis. These organisms released oxygen as waste, slowly, over unimaginably long periods of time. Oxygen accumulated in the atmosphere. At first, this oxygen was dangerous to many early life forms, but eventually, evolution adapted. New organisms learned to use oxygen because it allowed cells to produce far more energy than older biological systems. Over millions of years, complex life emerged. Plants spread across land. Forests appeared. Animals evolved. Human beings arrived at the very end of this enormous story, inheriting an atmosphere created by ancient life itself. In a strange way, every breath humans take today is connected to those distant oceans and microscopic organisms from deep time. The air in your lungs tonight has likely passed through forests, crossed continents, drifted above oceans, and circulated around the entire planet many times before reaching you. Some scientists even point out that a single breath probably contains atoms once inhaled by ancient humans, dinosaurs, or long-vanished creatures from Earth's past. This realization changes the search for alien worlds completely. A breathable atmosphere may not appear easily. It may require billions of years of stability. It may require oceans, magnetic fields, tectonic activity, and life itself working together. Earth did not simply receive perfect air from the beginning. Earth slowly became breathable through a chain of fragile events. That is why scientists searching distant planets become excited when they detect gases like oxygen, methane, or water vapor. These substances may hint that biological activity is shaping another atmosphere somewhere far away. Telescopes now study tiny changes in starlight passing through alien skies, searching for chemical fingerprints that might reveal whether another world could support life. Still, even if another planet contains oxygen, humans may not survive there easily. Alien pollen, bacteria, gravity, radiation, and unfamiliar chemistry could all create dangers. A breathable atmosphere alone does not guarantee comfort. Earth is not simply a place with oxygen. It is a complete living system where countless conditions happen to align perfectly for human biology. Tonight, while you rest safely beneath this ancient atmosphere, billions of invisible molecules are moving quietly around you. Oxygen enters your lungs. Carbon dioxide leaves your body. Air flows softly through forests, over mountains, and across sleeping oceans. And somewhere far beyond Earth, hidden among the stars, there may be another world where another atmosphere waits in silence beneath unfamiliar skies. Far above the oceans, above the storms, above the airplanes and drifting clouds, Earth is wrapped in an extraordinarily thin layer of air. From the ground, the atmosphere feels endless. The sky stretches across the horizon in every direction. Blue during the day and dark at night, giving the impression of something enormous and permanent. But astronauts who look back at Earth from orbit often describe a very different sight. They see a delicate glowing shell surrounding the planet. A faint blue line so thin that it almost disappears against the blackness of space. That fragile layer is all that separates humanity from a silent vacuum where breathing is impossible. If Earth were the size of a large classroom globe, the breathable atmosphere would be thinner than the paint covering its surface. Nearly every human in history has lived entirely within this tiny film of gas. Every city, forest, ocean voyage, war, conversation, and dream has existed beneath this narrow atmospheric blanket. It is easy to forget how fragile it really is because the atmosphere surrounds us constantly, pressing against our skin every second of our lives. Air has weight. This may sound strange because human beings move through it so easily, but the atmosphere presses downward continuously. At sea level, every person carries the weight of an invisible ocean of air above them. Human bodies do not notice this pressure because they evolved inside it. Our lungs, blood circulation, and even the fluids inside our cells are balanced perfectly with the atmosphere around us. As altitude increases, pressure begins to fall. Mountain climbers know this feeling well. On very high peaks, each breath contains fewer usable oxygen molecules. The body reacts with headaches, exhaustion, dizziness, and confusion. Some climbers experience hallucinations in the thin air above 8,000 meters. Their brains struggle to function properly as oxygen levels drop lower and lower. Above a certain height, humans cannot survive without pressurized equipment. Pilots flying at extreme altitudes wear oxygen masks. Astronauts leaving spacecraft wear pressurized suits because the human body cannot function in vacuum conditions. Blood and body fluids do not instantly boil in space, as movies sometimes suggest, but exposure would still be catastrophic. Within seconds, unconsciousness begins. Earth's atmosphere protects humanity from far more than suffocation. It also shields life from radiation pouring constantly through space. The sun emits enormous energy every second. Some of this energy gives warmth and light, making life possible, but some of it is dangerous. Ultraviolet radiation damages cells. Solar storms release streams of charged particles capable of harming living tissue. Fortunately, Earth possesses two powerful defenses. The first is the atmosphere itself, which absorbs and scatters much of this radiation before it reaches the ground. The second is Earth's magnetic field, an invisible force generated deep inside the planet by the movement of molten metal in the core. This magnetic field stretches far into space and deflects many dangerous solar particles away from the planet. Without these protections, Earth might resemble Mars. Scientists believe Mars once had a thicker atmosphere long ago. Ancient rivers flowed across its surface. Lakes may have existed. Some researchers think shallow seas may even have covered parts of the planet billions of years ago. But Mars is smaller than Earth, and over immense spans of time, it gradually lost much of its internal heat. Its magnetic field weakened and disappeared. Without strong magnetic protection, solar winds slowly stripped away much of the Martian atmosphere into space. Today, Mars is cold, dry, and exposed. The skies above its deserts appear dusty and pale. Atmospheric pressure there is less than 1% of Earth's. A human standing unprotected on Mars could not breathe, not because oxygen is completely absent, but because the atmosphere is far too thin to support human biology. This teaches scientists an important lesson. A breathable world requires stability over enormous periods of time. It is not enough for a planet to briefly possess air. The atmosphere must survive for billions of years while resisting radiation, solar winds, asteroid impacts, and changing climates. Earth itself has changed dramatically across history. There were periods when giant ice sheets covered vast regions of the planet. There were warmer ages when tropical forests reached far northward. Oxygen levels rose and fell over time. Ancient insects during some prehistoric eras grew much larger, partly because atmospheric oxygen was higher than today. Yet, through all these changes, Earth managed to preserve something extremely rare: long-term habitability. The atmosphere also performs another quiet miracle every night and day. It redistributes heat around the planet. Without air, temperatures would swing violently between burning sunlight and freezing darkness. The moon demonstrates this clearly. During lunar daytime, surface temperatures become incredibly hot. During lunar night, they plunge into extreme cold because there is almost no atmosphere to trap or circulate warmth. Earth's atmosphere softens these extremes. Winds move heat across continents and oceans. Clouds reflect sunlight. Water vapor stores energy. Storm systems transport moisture across entire hemispheres. The atmosphere behaves almost like a living circulation system for the entire planet. Even the color of the sky depends on it. Sunlight contains many colors mixed together, but molecules in Earth's atmosphere scatter blue light more strongly than other colors. That is why the daytime sky appears blue to human eyes. On worlds with different atmospheres, skies might look completely different. A thicker atmosphere could create pale orange skies. Different gases might produce greenish sunsets or purple horizons. Scientists searching for breathable worlds often begin with atmospheres because atmospheres reveal so much about planetary conditions. By studying how light passes through alien air, researchers can identify gases from astonishing distances. Oxygen, methane, carbon dioxide, and water vapor each leave distinct patterns in starlight. These chemical fingerprints allow humanity to investigate planets that no human being has ever visited. Somewhere tonight, powerful telescopes are observing distant stars, while computers analyze tiny fluctuations in light. Entire teams of scientists are searching for signs of atmospheres similar to Earth's. Not necessarily identical, but stable enough, gentle enough, and rich enough to perhaps support life. Yet the more humanity studies Earth, the more extraordinary our own atmosphere appears. It is not merely a layer of gas. It is the result of countless interconnected systems balancing one another continuously. Oceans absorb carbon dioxide. Forests release oxygen. Microorganisms influence clouds. Ice reflects sunlight. Volcanoes release gases from deep underground. The entire planet participates in maintaining the conditions humans depend upon. Tonight, somewhere beneath drifting clouds and quiet stars, billions of people are breathing without effort. The atmosphere presses softly around every sleeping city and every dark ocean. Above that thin blue line waits an immense universe filled mostly with silence, radiation, frozen worlds, and toxic skies. And still humanity continues searching for another place where the simple act of breathing might someday feel natural again. When scientists talk about a habitable planet, they're not usually imagining beautiful forests, quiet beaches, or peaceful green valleys beneath blue skies. At least not at first. In astronomy, the word habitable has a far more careful meaning. It simply refers to whether a world might support liquid water and stable conditions long enough for life to exist. Human comfort comes much later in the conversation. This distinction matters because the universe contains many worlds that seem promising from a distance, yet become frighteningly hostile when examined more closely. A planet may orbit at the correct distance from its star and still possess poisonous air. Another may contain oceans hidden beneath ice while enduring deadly radiation at the surface. Habitability is not one single condition. It is a delicate chain of connected requirements, each depending on the others. The first requirement is usually temperature. Liquid water can only exist within a certain range. If a planet becomes too cold, water freezes into ice. If it becomes too hot, oceans evaporate into vapor. Scientists often call the region around a star where liquid water may exist the habitable zone, or sometimes the Goldilocks zone, meaning conditions are neither too hot nor too cold. Earth sits comfortably inside this region around the Sun. Venus lies closer to the Sun and became unimaginably hot. Mars lies farther away and became cold and dry. Earth happens to orbit in a narrow region where oceans remained stable for billions of years. That single fact may have shaped the entire history of life. But distance from a star alone is not enough. The atmosphere changes everything. Imagine two identical planets orbiting the same star. One has a thick atmosphere filled with greenhouse gases that trap heat. The other has almost no atmosphere at all. Even though both planets receive similar sunlight, their surface conditions could be completely different. Venus demonstrates this dramatically. Its thick atmosphere traps enormous amounts of heat through a runaway greenhouse effect. Surface temperatures there are hot enough to melt lead. Mars, with its thin atmosphere, cannot retain heat effectively and remains freezing cold much of the time. Earth rests in a remarkable balance between these extremes. Our atmosphere traps enough warmth to keep oceans liquid while avoiding the crushing heat found on Venus. Clouds, oceans, forests, and even microscopic organisms all contribute to maintaining this balance. Gravity also plays an important role in habitability. A planet must possess enough gravity to hold onto an atmosphere for long periods of time. Small worlds struggle with this. Their weaker gravity allows gases to slowly escape into space over millions or billions of years. Mars likely lost much of its atmosphere, partly because of its lower gravity. Earth, being larger, holds its atmosphere more effectively. However, too much gravity creates different problems. On a massive planet, human beings might struggle simply to walk. Bones and muscles evolved under Earth's gravity. Even modest increases could make movement exhausting. Blood circulation would become more difficult. Falling objects would strike harder. Over time, human bodies living permanently under stronger gravity might evolve differently or require technological assistance. The star itself matters enormously too. Our sun is relatively stable compared to many stars in the galaxy. Some stars produce violent flares capable of blasting nearby planets with intense radiation. Others burn inconsistently, causing extreme temperature swings. Red dwarf stars, the most common stars in the universe, often release enormous stellar flares that could strip atmospheres from nearby planets or damage living organisms on their surfaces. And then there is time. Life on Earth did not appear overnight. Complex animals required billions of years to evolve. This means habitable conditions must remain stable across incomprehensible stretches of time. A planet that remains comfortable for only a few million years may never develop advanced life at all. Stability may be just as important as the conditions themselves. Earth's moon also quietly contributes to habitability. The moon stabilizes Earth's axial tilt, preventing chaotic shifts in climate over long periods. Without the moon, Earth's seasons might vary far more dramatically. Oceans might behave differently. Climate instability could interfere with the long development of complex ecosystems. Even Jupiter may have helped life survive on Earth. Its enormous gravity influences asteroids and comets throughout the solar system. Some scientists think Jupiter acts partly like a cosmic shield, reducing certain impacts on Earth, though the situation is more complicated than once believed. Still, giant planets can strongly shape the architecture and stability of planetary systems. The deeper scientists study habitability, the more complicated the concept becomes. A truly Earth-like world may require dozens of favorable conditions occurring together at the same time. The correct star, the correct orbit, the correct atmosphere, stable temperatures, a magnetic field, long-term geological activity, water, chemical balance, perhaps even the right neighboring planets and moons. And yet the galaxy is unimaginably large. The Milky Way alone contains hundreds of billions of stars. Around many of these stars orbit planets. Modern telescopes have revealed that planets are not rare at all. Some systems contain tightly packed worlds orbiting dim red stars. Others possess giant planets larger than Jupiter. There are planets with 2 suns, planets drifting freely through space without stars, and rocky worlds far larger than Earth. Astronomers now estimate that billions of potentially habitable planets may exist in our galaxy alone. Not confirmed Earth twins, but worlds existing within ranges where liquid water could potentially survive. Somewhere among those countless distant worlds, some may possess calm oceans beneath breathable skies. But habitability for microbes and habitability for humans are not necessarily the same thing. Tiny organisms can survive in astonishingly harsh environments. On Earth, life exists near volcanic vents deep beneath oceans, inside Antarctic ice, and within acidic lakes. Human beings are far more fragile. We require not only survival, but comfort, stability, food systems, and long-term protection from radiation and disease. A distant planet could support alien bacteria while remaining lethal to humans. Another world might possess breathable oxygen but toxic plants or microorganisms. An ocean planet may have no dry land at all. A tidally locked planet orbiting a red dwarf star might have one side trapped in endless daylight, while the other remains frozen in eternal darkness. Still, despite all these difficulties, humanity keeps searching. Every new telescope launched into space carries the same quiet hope. Somewhere in the darkness may exist another pale world with clouds drifting above oceans. Somewhere there may be rain falling onto rocky coastlines beneath alien stars. Somewhere another atmosphere may move gently through forests unknown to Earth. And perhaps, on that distant world, if a human traveler one day stands beneath the sky and slowly removes a helmet, the first breath might feel strangely familiar. Of all the worlds in the night sky, Mars has captured the human imagination more than any other planet. Even before telescopes existed, ancient civilizations noticed its strange red color drifting among the stars. To the Romans, it represented war. To others, it looked like a burning ember suspended in darkness. Unlike the calm white glow of Venus or the steady brightness of Jupiter, Mars carried an unsettling appearance, reddish and alive, almost like a watching eye in the sky. Tonight, if the skies above Earth are clear enough, Mars is still there, moving silently through space exactly as it has for billions of years. Cold, dusty, and quiet. For a long time, humans imagined Mars as a living world. In the 19th century, some astronomers believed they saw artificial canals crossing its surface. Newspapers described dying Martian civilizations, building enormous waterways to survive on a drying planet. Science fiction writers filled Mars with cities, deserts, ruins, and intelligent beings staring back toward Earth across space. The truth turned out to be both less dramatic and more haunting. When spacecraft finally reached Mars in the 20th century, they found not cities but emptiness. Endless deserts stretched beneath pale skies. Craters covered ancient landscapes untouched for millions of years. Dry river valleys cut across the terrain, proving that water once flowed there long ago. Mars was not alive in the way people imagined, but it also was not completely dead. Instead, it appeared frozen somewhere between past habitability and present ruin. Mars is smaller than Earth, only about half the diameter. Gravity there is weaker, roughly 38% of Earth's gravity. If you stood on Mars, your body would feel strangely light. Walking would require less effort. A person could jump farther and carry heavier objects more easily. Dust would drift slowly downward through the thin atmosphere. That atmosphere is one of the greatest problems. Mars possesses air, but not air humans can breathe. Its atmosphere is composed mostly of carbon dioxide, with only tiny traces of oxygen. Worse still, the atmosphere is extremely thin. Surface pressure on Mars is so low that liquid water struggles to remain stable for long. Exposed water tends to freeze or evaporate quickly in the cold, dry conditions. A human standing unprotected on Mars would lose consciousness rapidly. Breathing would be impossible. Specialized suits providing oxygen and pressure would be necessary every moment outdoors. And yet Mars remains the most realistic candidate for future human exploration, and perhaps even settlement. Why? Because beneath its harsh surface, Mars still resembles Earth more than any other planet humans have ever discovered nearby. A Martian day is surprisingly similar to an Earth day, lasting just over 24 hours. Mars has seasons because its axis is tilted like Earth's. Polar ice caps grow and shrink over time. Clouds drift through the atmosphere. Dust storms sweep across entire regions, sometimes covering nearly the whole planet in reddish haze. Most importantly, Mars once possessed conditions that may have supported life. Billions of years ago, Mars was warmer and wetter. Rivers carved channels into rock. Lakes collected in giant basins. Some scientists think northern regions may even have contained shallow oceans. The planet likely possessed a thicker atmosphere, capable of supporting stable liquid water. Ancient Mars may have looked strangely familiar in some places, cold, perhaps, but active and dynamic. Then something changed. Because Mars is smaller than Earth, its interior cooled faster. Geological activity slowed. Its magnetic field weakened and eventually disappeared. Without magnetic protection, solar winds gradually stripped away much of the atmosphere. As pressure dropped, temperatures fell. Water vanished from the surface. The planet slowly transformed into the frozen desert visible today. This transformation fascinates scientists because it demonstrates how fragile planetary habitability can be. Mars may once have stood near the edge of becoming a truly life-supporting world. Instead, it became a warning about atmospheric collapse and planetary vulnerability. Even now, however, Mars still hides water. Large amounts of frozen water exist at the poles and beneath the surface. Orbiting spacecraft have detected signs of underground ice across wide regions of the planet. Some researchers suspect that salty liquid water may occasionally exist beneath the surface in certain locations, though this remains debated. For future human explorers, water means survival. Water can be purified for drinking. It can be separated into hydrogen and oxygen. Oxygen could support breathing. Hydrogen and oxygen together could create rocket fuel. A future Martian settlement would depend heavily on extracting resources directly from the planet itself. Scientists and engineers already imagine what such settlements might look like. Because radiation levels on Mars are much higher than on Earth, many proposed habitats would likely be built underground or covered with thick layers of soil for protection. Inflatable living modules may connect through tunnels beneath the surface. Artificial lighting could support crops grown inside controlled environments. Machines would continuously recycle air and water. The first humans arriving on Mars would experience a strange and lonely existence. Outside their habitats would stretch silent red deserts beneath salmon-colored skies. Sunsets on Mars appear blue near the horizon because of the way fine dust scatters light. During the day, the sun looks smaller than it does from Earth. Dust devils wander across plains. Thin winds move quietly through ancient craters. And above all of it hangs an enormous silence. Mars has no birds, no forests, no ocean waves, no rain tapping against windows. Human voices inside habitats may become the only sounds for vast distances. Every breath would depend on technology. Every greenhouse would become precious. Every machine generating oxygen would quietly sustain life in a world never meant for human lungs. Still, many people believe humanity will eventually walk there. Robotic explorers already roam the Martian surface. Machines like the rover's Spirit, Opportunity, Curiosity, and Perseverance have crossed deserts, climbed hills, studied rocks, and searched for signs of ancient habitability. Small helicopters have even flown through the thin atmosphere, proving powered flight is possible on another planet. Each mission reveals more evidence that Mars was once very different. Ancient river deltas, mineral deposits formed in water, organic molecules preserved in rocks. The planet keeps whispering hints about a wetter and potentially more habitable past. Perhaps that is why Mars feels emotionally important to humanity. It is close enough to imagine standing there, familiar enough to recognize landscapes that resemble deserts or frozen valleys on Earth, yet alien enough to remind us how rare our own atmosphere truly is. Tonight, Mars continues orbiting the Sun beside Earth, separated by millions of kilometers of darkness. Beneath its dusty skies lie the remains of rivers that vanished before human beings even existed. And somewhere in the imagination of humanity, future footsteps are already echoing softly across those cold red plains. If Mars feels like a frozen memory of what a living planet might once have been, Venus feels like a warning. From Earth, Venus is beautiful. It is often the brightest object in the night sky after the moon, shining with a soft white glow near sunrise or sunset. Ancient people admired it for thousands of years. Some cultures called it the morning star. Others imagined it as a symbol of beauty, love, or divine light. But beneath those bright clouds lies one of the most hostile worlds ever discovered. Venus is sometimes called Earth's twin because the two planets are surprisingly similar in size and structure. Venus is only slightly smaller than Earth. It had likely formed from similar materials in the early solar system. Both planets are rocky worlds orbiting relatively close to the Sun. At first glance, scientists once imagined Venus might possess jungles, oceans, or even life hidden beneath thick clouds. Instead, they found an inferno. The surface of Venus is hot enough to melt lead. Temperatures reach around 460 degrees Celsius across almost the entire planet, day and night. The atmosphere is so thick and heavy that pressure at the surface is crushing, comparable to being deep beneath Earth's oceans. The air itself is composed mostly of carbon dioxide, wrapped in clouds filled with sulfuric acid droplets. A human being standing unprotected on Venus would survive only moments. Yet Venus may once have been far more Earth-like than it is today. This possibility fascinates scientists because it suggests that habitability is not permanent. A world may begin with oceans and moderate temperatures, then slowly transform into something catastrophic. Venus may represent an alternate version of Earth, a glimpse of how differently planetary history can unfold. Long ago, Venus may have possessed liquid water. Some climate models suggest shallow oceans could have existed there billions of years ago. If early Venus truly contained water and a milder atmosphere, then at some point, the planet experienced one of the greatest climate disasters in the solar system. The likely cause was a runaway greenhouse effect. Greenhouse gases trap heat inside an atmosphere. On Earth, this process is natural and necessary. Without greenhouse warming, our planet would be frozen and uninhabitable. But if greenhouse gases accumulate excessively, temperatures rise further, causing more water vapor to enter the atmosphere. Water vapor itself is also a greenhouse gas, which traps even more heat. This feedback loop can spiral out of control. Scientists believe something like this happened on Venus. As temperatures increased, oceans may have slowly evaporated. Water vapor entered the atmosphere and intensified warming. Eventually, the process accelerated until enormous amounts of heat became trapped permanently. Solar radiation then broke apart water molecules high in the atmosphere. Lightweight hydrogen escaped into space. Without water remaining to regulate climate, Venus transformed into the furnace seen today. The tragedy of Venus is not merely that it became uninhabitable. It is that it may once have stood very close to habitability. Even now, Venus and Earth remain neighbors in space. Sometimes Venus drifts closer to Earth than any other planet does, yet the conditions between them could hardly be more different. Earth supports forests, oceans, clouds, and breathing life. Venus crushes and burns nearly everything that reaches its surface. The sky on Venus would feel deeply unsettling to human senses. Thick clouds cover the planet continuously, meaning the surface never experiences a clear blue sky. Sunlight struggles to penetrate the dense atmosphere. Daytime on Venus would appear dim and orange, with heavy haze stretching in every direction. The atmosphere scatters light so intensely that shadows would seem weak and blurred. The winds high above Venus are astonishingly fast, circling the planet far quicker than the planet itself rotates. Curiously, Venus rotates extremely slowly. One Venusian day lasts longer than its year. Even stranger, the planet rotates backward compared to most planets in the solar system. On Venus, the sun would appear to rise in the west and set in the east. The surface itself is filled with volcanic plains, massive lava flows, and enormous mountains. Thousands of volcanoes cover the planet. Some may still be active today. Radar mapping from orbiting spacecraft has revealed landscapes buried beneath clouds that no human eye has ever directly seen from the ground. Landing on Venus is extraordinarily difficult. Several Soviet spacecraft managed to survive briefly on the surface during the 20th century, transmitting images before being destroyed by heat and pressure. The photographs are haunting. Flat rocky terrain stretches beneath dim yellow light. The atmosphere appears thick and oppressive, almost like being underwater. Yet, despite all this hostility, scientists continue studying Venus intensely. Why? Because Venus may help humanity understand planetary climate, atmospheric evolution, and the delicate balance required for long-term habitability. By comparing Earth and Venus, researchers learn how small differences can lead to dramatically different futures. Some scientists have even proposed astonishing ideas for surviving there. While the surface is deadly, conditions higher in the atmosphere are somewhat less extreme. At certain altitudes, temperatures and pressures become surprisingly Earth-like. This has led to speculative concepts involving floating cities suspended within Venusian clouds. Giant airships filled with breathable air could theoretically float because Earth-like air is lighter than the surrounding carbon dioxide atmosphere. Inside such floating habitats, humans might one day drift above the deadly surface beneath orange skies. Outside the windows would stretch endless clouds, glowing softly in filtered sunlight. Far below, hidden beneath haze, lies one of the most hostile surfaces in the solar system. The idea sounds almost like science fiction, yet it reveals something important about humanity. Even in places where breathing naturally is impossible, people continue imagining ways to survive. Venus also reminds scientists that breathable worlds may be extremely fragile. A planet can begin within the habitable zone and still lose everything that once made it comfortable. Oceans may vanish. Atmospheres may thicken uncontrollably. Temperatures may rise beyond recovery. The universe does not guarantee stability. Tonight, Venus still shines brightly in the skies above Earth, beautiful from a distance, terrifying up close. Beneath its glowing clouds lies a world that may once have held water beneath calmer skies. Now it exists as a planet that lost its breath, wrapped forever in heat and silence while drifting beside a living Earth. Beyond Mars, the solar system begins to change dramatically. The rocky planets slowly disappear behind us, and the enormous giant worlds emerge from the darkness. Jupiter, Saturn, Uranus, and Neptune are unlike Earth in almost every possible way. They are not places where humans could stand on solid ground beneath open skies. In fact, some of them may not even possess a true surface at all. And yet, despite their hostility, These distant giants remain some of the most mesmerizing worlds humanity has ever discovered. If you could travel outward through the solar system tonight, leaving behind the warmth of the inner planets, the sun would gradually shrink into a smaller and colder light. The space between worlds would become vast and quiet. Asteroids would drift silently through darkness. Temperatures would fall lower and lower, then eventually, appearing ahead like an enormous striped sphere hanging in black space, Jupiter would come into view. Jupiter is so large that more than 1,000 Earths could fit inside it. From a distance, it looks almost peaceful. Cream-colored clouds wrap around the planet in smooth bands. Vast storms swirl slowly across the atmosphere. But Jupiter is not calm. It is violent beyond ordinary human imagination. The planet is composed mostly of hydrogen and helium, the same elements that form stars. Its atmosphere grows thicker and denser with depth. There is no clear boundary where sky becomes ground. Instead, descending into Jupiter would mean falling deeper and deeper into crushing pressure and rising temperatures. At first, the upper atmosphere might seem strangely beautiful. Towering cloud formations stretch across enormous distances. Lightning storms erupt within dark layers beneath the visible clouds. Winds roar faster than the strongest hurricanes on Earth. The famous Great Red Spot, a gigantic storm larger than Earth itself, has been raging for centuries, perhaps much longer. But lower down, the atmosphere becomes deadly. Pressure increases rapidly. Human bodies, spacecraft, and eventually even atoms themselves would struggle under the immense compression. Hydrogen gas deep inside Jupiter may transform into exotic forms, such as metallic hydrogen, a strange state where hydrogen behaves almost like liquid metal. Temperatures climb to extraordinary levels. There is no breathable air, no stable land, no place where human lungs could function naturally. And yet Jupiter plays a crucial role in the story of habitability. Its enormous gravity shapes the architecture of the solar system. It influences asteroid paths, affects comet orbits, and helps stabilize certain planetary motions. Without Jupiter, Earth's history may have unfolded very differently. Some scientists believe giant planets like Jupiter may even influence whether smaller rocky worlds remain stable enough for life over billions of years. Saturn, farther outward, appears even more dreamlike. Its rings stretch across space in astonishing beauty, formed from countless particles of ice and rock, orbiting together like frozen dust illuminated by sunlight. Seen through a telescope, Saturn hardly looks real. It resembles something delicate and artistic, rather than a giant world of storms and crushing pressure. But Saturn, too, is hostile to human life. Its atmosphere consists mainly of hydrogen and helium. Winds race through the upper atmosphere at incredible speeds. Deep inside, pressure rises until ordinary matter behaves in unfamiliar ways. Some scientists think diamonds may form within the atmospheres of Saturn and Jupiter under intense pressure before sinking deeper into the planets. The farther humanity studies these giants, the stranger they become. Uranus rotates on its side, as though knocked over long ago by an enormous collision. Its pale blue atmosphere contains hydrogen, helium, and methane gas, which gives the planet its icy color. Seasons on Uranus are extreme beyond anything on Earth because of its tilted orientation. Parts of the planet experience decades of continuous sunlight followed by decades of darkness. Neptune, even farther from the sun, is cold, dark, and swept by some of the fastest winds in the solar system. Despite receiving very little solar warmth, storms still rage across its atmosphere. Supersonic winds race through deep blue clouds beneath faint sunlight. None of these giant planets are breathable worlds. Human beings could never simply land there and survive. Yet their existence teaches scientists important lessons about planetary systems and the possibilities of alien worlds beyond our own solar system. In fact, Many of the first planets discovered around other stars were giant worlds much larger than Earth. Some orbit extremely close to their stars, becoming scorching hot gas giants called hot Jupiters. Others drift far away in deep, cold darkness. These discoveries revealed that planetary systems can form in ways very different from our own. Some exoplanets may even be enormous gas worlds with floating layers where temperatures and pressures briefly resemble conditions suitable for life. Scientists have imagined speculative forms of life drifting through alien atmospheres, enormous biological organisms floating like living balloons above endless clouds. Such ideas remain hypothetical, but they show how broad the search for habitability has become. Still, for human beings, the giant planets remain impossible homes. There is no oxygen to breathe, no forests, no rivers, no quiet beaches or grassy hills. Only storms, pressure, radiation, and darkness stretching across worlds larger than imagination itself. Jupiter in particular produces intense radiation belts powerful enough to damage spacecraft and endanger astronauts. Any future missions near its moons must carefully consider this invisible danger. Even approaching the giant planets requires extraordinary engineering. And yet, despite their hostility, these worlds possess an undeniable beauty. Imagine floating high above Saturn's cloud tops, while the rings arc across the sky like glowing silver rivers. Imagine watching lightning storms larger than continents flash within Jupiter's atmosphere. Imagine drifting above Neptune, beneath deep sapphire clouds, while the distant sun shines like a bright star far away. The giant worlds remind humanity that the universe is not designed around human comfort. Most planets are not gentle. Most skies cannot be breathed. Most worlds would destroy us almost instantly. And still, hidden among these hostile giants, something remarkable exists. Moons. Dozens and dozens of moons orbit the giant planets, and some of them may contain oceans, atmospheres, underground seas, and perhaps conditions surprisingly favorable for life. While the giant planets themselves are deadly, their moons may hold some of the most intriguing environments in the solar system. Tonight, far beyond Earth, Jupiter and Saturn continue turning silently in the dark, wrapped in storms older than human civilization. Around them circle frozen worlds hiding secrets beneath ice and shadow. And somewhere beneath those distant surfaces, protected from the deadly skies above, water may still move quietly through alien oceans untouched by human eyes. For a long time, humanity assumed that life could only exist on warm planets beneath open skies. Oceans needed sunlight. Atmospheres needed balance. Breathing worlds, people believed, had to resemble Earth at least a little. But as telescopes improved and robotic spacecraft traveled deeper into the solar system, scientists discovered something unexpected. Some of the most promising places for life may not be planets at all. They may be frozen moons orbiting giant worlds in the cold outer darkness of the solar system. At first glance, these moons appear lifeless. Their surfaces are covered in ice, scarred by impacts, and frozen beneath temperatures so low that human skin would freeze almost instantly. Sunlight there is weak and distant. The sky would look dark even during daytime. Nothing about these worlds feels welcoming. And yet beneath the frozen crusts of some of these moons, hidden far below the ice, entire oceans may exist. These hidden seas fascinate scientists because liquid water is one of the most important ingredients associated with life. On Earth, wherever liquid water exists, life almost always appears. Tiny microorganisms survive in boiling springs, beneath Antarctic ice, deep underground, and near volcanic vents at the bottom of oceans. Life adapts with astonishing persistence. So when scientists discovered evidence of underground oceans beyond Earth, the search for life changed forever. One of the most intriguing examples is Europa, a moon of Jupiter. From a distance, Europa looks smooth and pale, covered in cracked ice stretching across its entire surface. The moon is slightly smaller than Earth's moon, yet beneath that icy shell may lie a global ocean containing more water than all of Earth's oceans combined. The surface temperature on Europa is brutally cold, but deep below the ice, something keeps the hidden ocean liquid. The answer is gravity. Europa is constantly squeezed by Jupiter's immense gravitational pull. As the moon orbits the giant planet, tidal forces flex and stretch its interior slightly, generating heat through friction. This process, called tidal heating, may warm the underground ocean enough to keep water liquid despite the freezing conditions above. In darkness, beneath kilometers of ice, an entire alien ocean may slowly move through silent black water. Scientists find this possibility deeply exciting because life on Earth does not always depend directly on sunlight. Deep beneath Earth's oceans, near hydrothermal vents, ecosystems thrive entirely on chemical energy rising from the planet's interior. Strange organisms survive there without sunlight at all. If similar vents exist on Europa's ocean floor, then some form of life could theoretically survive there too. Not necessarily intelligent creatures or giant sea monsters, but perhaps microscopic organisms drifting through dark waters beneath the ice. Another remarkable moon is Enceladus, orbiting Saturn. Enceladus is much smaller than Europa, yet it astonished scientists when spacecraft observed enormous plumes of water vapor erupting from cracks near its south pole. These geysers spray material from the underground ocean directly into space. Imagine that for a moment. A frozen moon hundreds of millions of kilometers from Earth quietly releasing hidden ocean water into the darkness. When spacecraft flew through these plumes, scientists detected water, salts, organic molecules, and chemical signs suggesting hydrothermal activity deep below the surface. It was one of the most important discoveries in modern planetary science because it meant humanity could study material from an alien ocean without drilling through kilometers of ice. Then there is Titan, Saturn's largest moon, one of the strangest places in the entire solar system. Titan possesses a thick atmosphere richer than any moon in the solar system. Lakes and rivers exist there, but they are not made of water. Instead, they contain liquid methane and ethane, hydrocarbons flowing across a frozen landscape colder than almost anywhere humans have ever explored. Rain falls on Titan, rivers carve channels, winds shape dunes, clouds drift through orange skies. In many ways, Titan resembles Earth, but with entirely different chemistry, and beneath Titan's icy crust, scientists also suspect a hidden water ocean may exist. These discoveries transformed humanity's understanding of habitability. A world no longer needed to orbit perfectly within a traditional habitable zone. Internal heating, underground oceans, and chemical energy could create environments where life might survive even in deep space, far from warmth and sunlight. Still, these moons are not breathable worlds for humans. Europa's surface is bombarded by intense radiation from Jupiter. Titan's atmosphere lacks oxygen and remains lethally cold. Enceladus is tiny, frozen, and airless. Humans would require sealed habitats, constant life support systems, and protection from extreme environments. Yet emotionally, these moons affect people differently than barren planets do. Mars feels empty, but familiar. Europa and Enceladus feel mysterious. Beneath their icy shells may exist untouched oceans older than human civilization itself. Water currents may move slowly through endless darkness. Minerals may rise from hidden seafloors. Somewhere in those alien depths, microscopic life could already exist without Earth ever knowing. The imagination naturally wanders there. What would it feel like to descend through Europa's ice into the hidden sea below? At first there would be silence, then darkness deeper than any ocean on Earth. Lights from a submarine would illuminate drifting particles in black water untouched for billions of years. Strange ice formations might hang above like underwater mountains. The ocean would stretch endlessly beneath the frozen shell. And somewhere in that darkness, perhaps tiny living organisms drift slowly through warm currents, rising from volcanic vents below. The idea changes how humanity thinks about life in the universe. Perhaps breathable Earth-like planets are not the only places where biology can emerge. Perhaps the galaxy contains countless hidden oceans beneath frozen surfaces. Worlds that appear dead from above may secretly hold moving water and living chemistry below. Even Earth itself may offer clues. Some scientists believe life on our planet may have first emerged deep beneath the oceans where hydrothermal systems provided energy and protection from harsh surface conditions. If that is true, then underground oceans elsewhere become even more intriguing. Future missions are already being planned. Robotic probes may one day drill into ice, explore subsurface oceans, or analyze plumes more carefully. Tiny submarines might eventually swim through alien waters beneath frozen crusts. Humanity is slowly approaching a moment where another living ecosystem could finally be discovered beyond Earth. Tonight, while Earth's oceans move beneath moonlight and drifting clouds, other oceans may also exist far away in the dark outer solar system, hidden beneath ice, untouched by sunlight. Silent waters may already be carrying the first fragile signs of life through worlds where no human being has ever breathed. Among all the moons of the solar system, Titan feels the most strangely familiar. Not because humans could survive there easily, and certainly not because its air is breathable, but because Titan possesses something very few worlds beyond Earth have. Weather. Clouds drift through its skies. Rain falls onto its surface. Rivers carve channels through the landscape. Lakes gather in low regions. Winds move across dunes stretching for hundreds of kilometers. In photographs and radar images sent back by spacecraft, Titan almost looks like a dream version of Earth, transformed by cold and wrapped in orange haze. If a human could stand safely on Titan tonight, the experience would feel surreal from the very first moment. The sky would glow dimly orange above endless frozen plains. Thick atmospheric haze would blur the horizon. Sunlight, weakened by Saturn's enormous distance from the sun, would appear faint and distant, almost like late evening on Earth, even during daytime. The air pressure at the surface would actually be slightly higher than Earth's, meaning a human would not need a pressurized suit there. But breathing would still be impossible because Titan's atmosphere contains almost no oxygen. Instead, Titan's air is made mostly of nitrogen with methane and other hydrocarbons mixed throughout. In some ways, Titan's atmosphere resembles what scientists think Earth's atmosphere may have looked like long before oxygen filled the skies. Studying Titan is almost like looking backward through time toward the conditions of the ancient Earth. The cold, however, is overwhelming. Titan's surface temperature is around -179 degrees Celsius. Water there behaves almost like rock. Ice becomes as hard as stone. Rivers and lakes are not filled with water at all, but with liquid methane and ethane, chemicals that remain liquid under Titan's freezing conditions. Imagine standing beside a dark methane lake beneath an orange sky while slow waves move quietly across the surface. Strange icy pebbles crunch beneath your boots. Far away, methane rain falls softly across frozen hills. The scene would feel oddly calm and deeply alien at the same time. Titan fascinates scientists because it possesses an active cycle similar to Earth's water cycle. On Earth, water evaporates, forms clouds, falls as rain, and flows through rivers into oceans. On Titan, methane performs a similar role. Methane evaporates into the atmosphere, forms clouds, falls as rain, and collects into lakes and seas. This means Titan is one of the very few places in the solar system with stable liquid flowing across its surface. Some of Titan's lakes are enormous. Kraken Mare, one of its largest methane seas, stretches across vast distances, larger than many seas on Earth. Radar observations show coastlines, channels, and wave patterns moving across the liquid surface. Humanity discovered an entire weather system operating on a moon more than 1 billion kilometers away from Earth. The atmosphere itself is remarkably thick. In fact, Titan's dense air may make flight easier there than almost anywhere else in the solar system. Because gravity is lower and the atmosphere is thicker, humans equipped with artificial wings might theoretically glide through Titan's skies with surprisingly little effort. But despite these fascinating qualities, Titan remains deadly for unprotected humans. The extreme cold alone would destroy exposed tissue almost instantly. There is no breathable oxygen. Sunlight is weak. Food does not exist naturally. Any future explorers would survive entirely through advanced habitats and life support systems. Still, Titan continues to attract enormous scientific interest because of its chemistry. The atmosphere and surface contain complex organic molecules, the building blocks associated with life. Sunlight interacting with methane and nitrogen creates thick layers of atmospheric haze and complicated chemical reactions. Some researchers think Titan may resemble conditions that existed on the young Earth before life emerged billions of years ago. In other words, Titan may preserve clues about how life itself begins. There is also evidence suggesting that beneath Titan's frozen crust lies another hidden ocean made of liquid water mixed with ammonia. So while methane rivers flow across the surface above, a completely different ocean may exist deep underground below. This combination makes Titan uniquely mysterious. It contains both Earth-like weather systems and deep hidden water oceans. It may hold chemistry similar to early Earth while existing in an environment utterly hostile to human life. When the spacecraft Huygens descended through Titan's atmosphere in 2005, humanity saw this strange moon up close for the first time. The probe drifted slowly downward beneath a parachute, while cameras captured the orange haze thinning around it. Dark river channels appeared below. Rounded icy stones covered the ground where the probe finally landed. For a brief moment, humanity had touched one of the most distant landscapes ever explored directly. The images remain hauntingly quiet. No trees moved in the wind. No animals crossed the plains. No waves crashed loudly along the methane shorelines. Just an alien silence beneath orange skies. Future missions are already being prepared. One planned mission called Dragonfly aims to send a nuclear-powered flying drone to Titan. Because of the moon's thick atmosphere and low gravity, such a vehicle could travel across enormous distances, exploring dunes, frozen plains, impact craters, and perhaps the edges of methane seas. Scientists hope these missions may answer deeper questions about chemistry, habitability, and the origins of life. Could entirely unfamiliar forms of life exist in methane-based environments? Could biology emerge differently elsewhere in the universe? Or is liquid water truly necessary for living systems? No one knows yet. Titan reminds humanity that the universe may be far stranger than people once imagined. Habitable conditions may not always resemble Earth closely. Entire worlds may operate under completely different rules of chemistry and climate. And yet, even on Titan, breathing remains the dividing line between survival and death. A human explorer there would carry Earth within their suit. Every breath would come from stored oxygen. Every warm shelter would recreate a tiny piece of home beneath the frozen orange mist. Tonight, while clouds drift quietly above Earth's oceans, methane rain may also be falling softly on Titan, far beyond the asteroid belt. Rivers of liquid hydrocarbons may be winding through frozen valleys under dim sunlight. And beneath miles of ancient ice, hidden oceans may still move silently in the dark, waiting for the day humanity finally arrives to listen. Far from the warmth of Earth, beyond the orbit of Mars and deep within Jupiter's enormous realm, a pale moon drifts through darkness wrapped in ice. From a distance, Europa appears smooth and bright, almost delicate. like a frozen pearl suspended in black space. Long reddish cracks stretch across its surface in tangled patterns, giving the moon the appearance of fractured glass. At first glance, Europa seems lifeless, silent, and completely frozen. But beneath that icy shell may exist one of the greatest hidden oceans in the solar system. Scientists believe Europa contains a vast global sea buried under kilometers of ice. More water may exist beneath Europa's surface than in all the oceans on Earth combined. The idea feels almost impossible. A frozen moon orbiting a giant planet may secretly hold enough liquid water to fill entire worlds. Unlike Earth's oceans, however, Europa's sea never sees sunlight. Imagine descending slowly through Europa's crust. Above you stretches thick ice colder than anything naturally found on Earth. The deeper you travel, the darker everything becomes. Eventually, the ice gives way to water, black and endless. No sunlight reaches these depths. No blue sky exists overhead. Only darkness, pressure, and silent currents moving beneath a frozen shell that seals the entire world. And yet scientists believe this hidden ocean may remain liquid because Europa is constantly being squeezed by Jupiter's immense gravity. As Europa orbits the giant planet, gravitational forces flex the moon continuously. This stretching generates internal heat through friction, warming the interior enough to prevent the underground ocean from freezing solid. The process is invisible from Earth, but deep inside Europa, enormous energy may quietly circulate through water and rock. Some researchers suspect hydrothermal vents may exist on Europa's seafloor, similar to the volcanic vents found deep beneath Earth's oceans. On our planet, these environments support rich ecosystems despite complete darkness. Strange creatures survive there using chemical energy instead of sunlight. Tiny organisms cluster around superheated mineral-rich water rising from the ocean floor. If something similar exists on Europa, then life may not only be possible there, it may already exist. Not forests or fish or breathing creatures beneath open skies, but perhaps microscopic organisms drifting through warm currents in eternal darkness. Alien life hidden beneath ice while Jupiter looms silently above. Europa fascinates humanity, partly because it challenges old ideas about where life can survive. For centuries, people imagined living worlds had to resemble Earth closely, with sunlight, breathable air, and moderate climates. Europa ignores nearly all those assumptions. Its surface is frozen and bombarded by radiation. There is no oxygen-rich atmosphere. Temperatures are brutally cold. Yet beneath the ice, conditions may still support biology. The surface itself is extraordinary. Europa contains surprisingly few impact craters compared to many other moons, suggesting the ice is relatively young and active. Huge cracks and ridges cover the landscape, formed as the frozen shell shifts and fractures over time. In some places, warmer material from below may rise closer to the surface before freezing again. Scientists think parts of the ice shell may slowly drift, almost like tectonic plates on Earth. Entire sections of frozen crust could separate, rotate, and refreeze over immense spans of time. Europa may not be geologically dead at all. It may be quietly active beneath its frozen exterior. And then there is the radiation. Europa orbits deep inside Jupiter's powerful radiation belts. The giant planet generates intense streams of charged particles that constantly bombard the moon's surface. Any human standing unprotected there would receive lethal radiation exposure very quickly. Future explorers would need heavily shielded habitats buried beneath ice or underground. Even landing on Europa presents enormous technical challenges. Spacecraft approaching the moon must survive Jupiter's harsh radiation environment. Temperatures remain dangerously low. The icy terrain is unpredictable. Yet despite all these difficulties, humanity continues preparing missions to explore Europa more closely. Why? Because Europa represents possibility. Somewhere beneath its crust may exist an independent living ecosystem completely separate from Earth. If life emerged there independently, it would mean biology may not be rare in the universe at all. It would suggest that whenever water, energy, and chemistry combine under stable conditions, life may eventually appear. That realization would change humanity forever. Imagine the first confirmed discovery of alien life beneath Europa's ice. Even microscopic organisms would prove that Earth is not alone. Biology would no longer belong exclusively to one planet. The universe would suddenly feel more alive and more mysterious than ever before. Future missions may search for this evidence carefully. Orbiting spacecraft will map the surface in greater detail, study the thickness of the ice, and analyze possible plumes of water vapor escaping into space. Some engineers dream of robotic probes, capable of melting through the ice shell itself. Small submarines might one day swim through Europa's hidden ocean beneath kilometers of frozen darkness. The journey would be slow and silent. Above the probe would stretch an entire world of ice. Below it, perhaps endless black water illuminated only by artificial lights. Tiny particles would drift through the darkness like underwater snow. Strange mineral towers might rise from the seafloor. Warm currents could move through hidden trenches untouched for billions of years. And somewhere in that alien sea, perhaps life already waits quietly. For humans, however, Europa will never be a naturally breathable world. Even if underground habitats are built one day, every breath would still depend on machinery, recycled air, and protection from radiation. The moon may hold water and perhaps life, but not comfort, not open skies, not forests moving in the wind. Still, Europa carries a certain emotional power, unlike almost any other world in the solar system. It is a place where something may be hidden beneath the surface, a world that appears frozen and dead from above while secretly containing moving oceans below. Tonight, while Earth's tides rise beneath moonlight and sleeping coastlines, another ocean may also be shifting far away around Jupiter. Beneath Europa's cracked ice shell, dark waters may still move silently through a hidden sea older than human civilization itself. And in that endless underwater night, life may already be breathing in forms humanity has never imagined. For most of human history, people could only wonder whether planets existed around other stars. The night sky looked filled with endless points of light, but nobody knew if those distant suns possessed worlds of their own. Philosophers imagined possibilities. Writers dreamed about alien civilizations beneath unfamiliar skies. Yet, there was no proof. Then, in the final years of the 20th century, humanity crossed an invisible boundary. Astronomers discovered the first confirmed planets orbiting distant stars. Everything changed after that. Suddenly, the universe became far larger and more populated than people once imagined. The solar system was no longer unique. Planets were everywhere. Today, scientists have confirmed thousands of exoplanets, worlds orbiting stars far beyond our sun. Some are giant gas worlds larger than Jupiter. Others are rocky planets resembling Earth in size. Some orbit close to blazing stars where temperatures melt metal. Others drift in deep, cold darkness. Entire systems of planets move silently around distant suns scattered across the galaxy. And among all these discoveries lies the question that continues to pull humanity forward through the darkness. Are any of these worlds breathable? The challenge of finding exoplanets is enormous. Stars are incredibly bright compared to the planets orbiting them. Trying to directly photograph a distant planet is almost like trying to see a tiny grain of dust beside a powerful lighthouse from thousands of kilometers away. So astronomers developed indirect methods. One of the most important techniques is called the transit method. When a planet passes in front of its star from Earth's perspective, it blocks a tiny fraction of the starlight. Sensitive telescopes can detect this small dimming. By observing these repeating patterns, scientists identify planets and estimate their sizes and orbits. Another method studies how stars wobble slightly because of the gravity of orbiting planets. Even massive stars move subtly under the pull of their worlds. By analyzing these motions carefully, astronomers can estimate planetary masses and distances. Over time, these techniques revealed something astonishing. The galaxy may contain more planets than stars. Some exoplanets are unlike anything found in our solar system. There are lava worlds where rock may flow like oceans beneath burning skies. There are giant planets orbiting so close to their stars that a year lasts only a few days. Some worlds may rain molten glass sideways in supersonic winds. Others drift freely through space without orbiting any star at all, wandering through eternal darkness as rogue planets. The universe turned out to be stranger than anyone expected. But among these bizarre worlds, scientists search carefully for rocky planets located within habitable zones. These are the planets most likely to possess stable liquid water and potentially Earth-like conditions. One famous system is TRAPPIST-1, located about 40 light-years away from Earth. This small red dwarf star possesses multiple rocky planets packed closely together. Several orbit within regions where liquid water could potentially exist. If you stood on one of these worlds, neighboring planets might appear enormous in the sky, far larger than the moon appears from Earth. Yet habitability around red dwarf stars remains uncertain. These stars often produce violent flares and intense radiation capable of damaging atmospheres. Planets orbiting close enough for warmth may also become tidally locked, meaning one side always faces the star while the other remains trapped in eternal darkness. Imagine such a world. On one side of the planet, endless daylight burns beneath a motionless sun hanging permanently overhead. On the other side, frozen darkness stretches forever under star-filled skies. Between them may exist a narrow twilight region where temperatures become moderate enough for liquid water and perhaps life. Some exoplanets are called super-Earths, rocky planets larger than Earth but smaller than Neptune. These worlds may possess thicker atmospheres, stronger gravity, and enormous oceans. Others are known as mini-Neptunes, wrapped in dense layers of gas and ice. Scientists now attempt something once considered impossible. They study the atmospheres of distant exoplanets. When starlight passes through a planet's atmosphere during transit, certain wavelengths are absorbed by gases present in the air. By analyzing these patterns carefully, astronomers can identify atmospheric chemicals from unimaginable distances. Oxygen, methane, water vapor, and carbon dioxide all leave unique signatures in light. This technique has become one of humanity's greatest tools in the search for breathable worlds. If astronomers ever detect strong oxygen levels combined with other signs of biological activity on a rocky planet within a habitable zone, the discovery would become one of the most important moments in human history. It would not prove intelligent life exists there, but it would strongly suggest active biological processes may be shaping the atmosphere. Still, distance remains a sobering reality. Even the nearest stars are unimaginably far away. Light itself, traveling at 300,000 kilometers per second, requires years to cross these distances. Current human technology would need tens of thousands of years to reach many nearby exoplanets. For now, humanity can observe these worlds, but not visit them. That limitation creates a strange emotional feeling. Somewhere tonight, breathable skies may already exist around another star. Rain may be falling across alien oceans. Forests may move in unfamiliar winds beneath constellations no human has ever seen from the ground. Entire living ecosystems may already thrive while Earth watches only from a distance. And perhaps somewhere out there, another civilization is asking the same question while studying our tiny blue world from far away. The search for exoplanets has also changed humanity's understanding of itself. Earth no longer feels isolated at the center of creation. Instead, it appears as one small planet among countless others scattered across a galaxy of staggering size. Yet the deeper scientists search, the more precious Earth seems. Many discovered worlds are extreme, unstable, or hostile. breathable atmospheres may be extraordinarily rare. Complex life may require delicate balances that few planets achieve. Every new discovery teaches humanity not only about distant worlds, but also about the fragile conditions that make our own existence possible. Tonight, while Earth turns quietly beneath its thin blue atmosphere, thousands of exoplanets continue orbiting distant suns across the Milky Way. Some burn beneath violent radiation. Some freeze in darkness. Some may hide oceans beneath clouds. And somewhere among them, perhaps beneath a calm sky around a distant star, another world may already be carrying the quiet sound of breathing life. When humans search for another breathable world, they are not looking first for cities, forests, or visible signs of life. They are looking for something much quieter, a chemical imbalance hidden inside light, across the darkness of space. Planets are too distant for scientists to walk upon or touch directly. Even the nearest exoplanets remain unimaginably far away. Yet astronomers have learned an extraordinary skill. They can study the air of alien worlds using nothing but starlight. Tonight, somewhere on Earth, giant telescopes are pointed toward distant stars while computers quietly analyze tiny shifts in light arriving from across the galaxy. Hidden inside that light may be clues about oceans, clouds, weather, and perhaps even breathing life. The process feels almost magical, though it is built entirely from physics and patience. When a planet passes in front of its star, a small amount of starlight filters through the planet's atmosphere before reaching telescopes. Different gases absorb different colors and wavelengths of light. Oxygen absorbs certain patterns. Methane absorbs others. Water vapor, carbon dioxide, and ozone each leave distinct fingerprints. By studying these patterns carefully, scientists can estimate which gases exist in alien atmospheres. This technique is astonishing when one truly thinks about it. Humanity has reached a point where people can investigate the chemistry of skies surrounding worlds that no human being may ever physically visit. Oxygen receives special attention because on Earth, it is strongly connected to life. Without biology, oxygen does not usually remain abundant in an atmosphere for very long. It reacts easily with rocks, minerals, and other chemicals. Earth's oxygen is constantly replenished by plants, algae, and microscopic organisms through photosynthesis. In other words, the breathable air humans depend upon is continuously maintained by living systems. If astronomers discovered a distant rocky planet with large amounts of oxygen alongside methane and water vapor, the combination would become extremely interesting. These gases tend to destroy one another chemically over time. If both remain abundant simultaneously, something may be actively replenishing them. On Earth, life performs exactly this role. Still, the search is complicated. Oxygen alone does not guarantee living organisms exist. Some planets may accumulate oxygen through non-biological processes. Water molecules can break apart under intense radiation, allowing hydrogen to escape into space while oxygen remains behind. A world may appear oxygen-rich while being completely sterile. Likewise, alien life may not even produce oxygen at all. Earth's atmosphere itself remained oxygen-poor for billions of years after life first emerged. Complex organisms capable of breathing oxygen evolved much later. This means a living planet could exist without producing obvious atmospheric signs detectable from Earth. Scientists therefore search not only for oxygen, but for combinations of gases, climate conditions, temperature ranges, and atmospheric stability. They study clouds, planetary density, orbital position, and stellar behavior. The search for breathable worlds becomes more detailed every year. The launch of powerful telescopes has transformed this effort dramatically. Instruments such as the James Webb Space Telescope allow astronomers to analyze exoplanet atmospheres with unprecedented precision. Some planets have already revealed signs of water vapor, carbon dioxide, methane, and thick cloud systems. For now, No truly Earth-identical atmosphere has been confirmed, but the list of potentially interesting worlds continues growing. Imagine standing on a distant exoplanet where oxygen fills the air naturally. The experience might still feel deeply alien. Gravity could differ from Earth's. Plants, if they exist, might appear black, silver, or dark red depending on the light from the local star. The sky itself could glow with unfamiliar colors shaped by atmospheric chemistry. Even sunsets would differ. On Earth, sunsets become orange and red because the atmosphere scatters shorter blue wavelengths while allowing longer red wavelengths to dominate near the horizon. On another world with different gases and particles, sunsets might glow purple, green, or deep crimson. Clouds could reflect strange colors across oceans no human has ever seen. And then there is smell. Earth's air carries the scent of oceans, forests, rain, soil, flowers, smoke, and living organisms. Alien atmospheres may smell metallic, sulfurous, salty, or chemically sharp. Some gases harmless to native life could irritate human lungs or damage tissue. Breathable does not necessarily mean comfortable. Even tiny changes in atmospheric composition can affect the human body dramatically. Too little oxygen causes confusion and unconsciousness. Too much oxygen increases fire risk and may damage tissues over long exposure. Carbon dioxide levels influence breathing reflexes. Pressure changes affect circulation and lung function. Human biology evolved very specifically for Earth. This realization leads scientists to another important idea. Truly, Earth-like worlds may be far rarer than merely habitable ones. Many planets may support some form of life while remaining unsuitable for unprotected humans. Humanity may eventually discover living worlds where people still require artificial habitats and breathing equipment. Yet, the dream persists. Somewhere in the galaxy, there may be a planet where the air pressure feels natural, where oxygen levels match human biology closely enough, where sunlight warms oceans beneath calm skies, and where a traveler could one day remove a helmet safely for the first time. That first breath would carry enormous emotional weight. Imagine hearing nothing but your own breathing inside a spacesuit after years of interstellar travel, then slowly opening the helmet beneath an alien sky. Cool air touches your face. Wind moves softly across an unfamiliar landscape. Your lungs hesitate for one uncertain moment before taking in air from another world. No machine between your body and the planet. No recycled oxygen tanks. Just atmosphere. Humanity has not reached that moment yet. Perhaps it will remain far in the future. But every telescope studying distant starlight tonight is part of that long search. Meanwhile, Earth continues performing its own atmospheric miracle quietly around us. Forests release oxygen into the air. Oceans absorb carbon dioxide. Microscopic organisms drift through clouds and seas, maintaining balances built over billions of years. Every comfortable breath humans take depends upon a living planet constantly renewing itself. Tonight, somewhere beneath distant stars, alien atmospheres are also moving around unseen worlds. Winds may be crossing dark oceans. Clouds may be gathering before unfamiliar storms. And hidden within the light reaching Earth tonight, the faint chemical signature of another breathable sky may already be traveling silently through space. Most people imagine stars as bright, golden suns, similar to the one shining above Earth. But in reality, our sun is not the most common type of star in the galaxy. The universe is filled mostly with smaller, dimmer stars called red dwarfs. These stars are quiet in appearance, faint and reddish compared to larger suns, yet they dominate the Milky Way in astonishing numbers. Nearly 3/4 of all stars in our galaxy may be red dwarfs. This means that if breathable planets exist elsewhere in the universe, many of them may orbit these small and distant suns. For scientists searching for life, red dwarfs create both excitement and uncertainty. A red dwarf star burns much more slowly than stars like our Sun. Some may survive for trillions of years, far longer than the current age of the universe itself. That incredible lifespan gives planets orbiting them enormous amounts of time for life to potentially emerge and evolve. At first, this sounds promising. Stable stars lasting trillions of years could provide ideal conditions for biology. But the reality is more complicated. Because red dwarfs are dimmer, planets must orbit much closer to receive enough warmth for liquid water. A habitable world around a red dwarf may circle its star far more closely than Earth circles the Sun. In some cases, the entire orbit may fit inside the orbit of Mercury in our own solar system. This closeness creates strange consequences. One major effect is tidal locking. Over long periods of time, gravity may force the planet to rotate in such a way that one side always faces the star. Just as the moon always shows the same face toward Earth, many exoplanets around red dwarfs may permanently show one hemisphere to their suns. Imagine living on such a world. On one side of the planet, the star never moves. It hangs endlessly in the same position above the horizon, shining day after day without setting. Temperatures there may become extremely hot, depending on atmospheric conditions. On the opposite side lies eternal night, a frozen hemisphere trapped beneath constant darkness and endless stars. Between these two extremes may exist a narrow twilight zone circling the planet like a ring. In this region, temperatures might remain moderate enough for oceans, clouds, and perhaps life. Winds would likely move continuously between the hot and cold hemispheres, creating powerful global weather systems unlike anything on Earth. The skies on such planets could feel deeply strange to human senses. If the red dwarf appears larger in the sky than our Sun, the daylight might glow dim red or orange rather than bright blue-white. Shadows could seem softer. Plants, if they exist, might evolve dark pigments optimized for red light. Some scientists imagine forests of black vegetation beneath copper-colored skies. Yet, red dwarfs introduce another serious challenge. Many are extremely active, especially during their younger years. They can produce powerful stellar flares capable of blasting nearby planets with intense radiation. Because habitable planets orbit so closely, they may receive repeated bursts of charged particles and ultraviolet light. Without strong magnetic fields and thick atmospheres, such planets could gradually lose their air to space. This possibility worries researchers because atmospheres are fragile. Earth's magnetic field quietly shields us from solar radiation every second. Without it, our atmosphere might slowly erode over immense spans of time. A planet orbiting an active red dwarf may struggle to maintain stable, breathable air. Still, not all red dwarfs are equally violent. Some appear calmer and more stable over time. Scientists continue discovering rocky planets around these stars, some remarkably Earth-sized and located within habitable zones. The TRAPPIST-1 system remains one of the most famous examples. 7 rocky planets orbit this tiny red star, several within potentially habitable distances. If oceans exist there, tides may behave differently because of strong gravitational interactions between neighboring planets. From the surface of one world, nearby planets might appear huge in the sky, glowing like giant moons. Imagine standing beside an alien ocean while another inhabited world hangs overhead larger than Earth's moon. Civilizations, if they existed there, might watch neighboring planets drifting through their skies every night. The emotional effect of such skies would be profound. Humanity evolved under a single moon and a stable yellow sun. Other worlds may experience entirely different rhythms of light and darkness, and perhaps that matters more than people once realized. Earth's cycle of day and night shapes nearly every living thing. Plants open and close with sunlight. Animals sleep according to circadian rhythms. Ocean tides respond to the moon. Seasonal changes influence migration, growth, and behavior. Life is deeply connected to the patterns of Earth's sky. On tidally locked planets, these rhythms may function differently. Some regions would never experience sunrise or sunset. Clouds might remain permanently fixed in certain areas. Massive storms could form where hot and cold air collide continuously. Yet, life is adaptable. On Earth, organisms survive in deserts, caves, frozen ice sheets, and deep oceans without sunlight. Biology repeatedly demonstrates an extraordinary ability to occupy difficult environments. If life emerged on red dwarf planets, it may adapt in ways humanity can barely imagine. For humans, however, survival on such worlds may remain difficult, even if breathable air exists. Radiation levels, atmospheric chemistry, gravity, and climate extremes could all present challenges. Future settlers might live beneath protective domes or underground habitats while studying alien ecosystems outside. Still, the sheer number of red dwarfs makes them impossible to ignore. If even a small fraction possess habitable planets, then the galaxy may contain enormous numbers of potentially life-supporting worlds. This realization changes the scale of the search completely. Humanity once wondered whether Earth was unique. Now scientists increasingly suspect that rocky planets are extremely common. Oceans, atmospheres, and habitable conditions may appear again and again across the galaxy under many different stars. And somewhere around a dim red sun tonight, another world may already exist beneath quiet crimson skies. Winds may move across dark oceans illuminated by eternal twilight. Clouds may drift slowly above unfamiliar continents. And perhaps beneath that distant red light, living creatures are already breathing air shaped by a completely different star. As astronomers began discovering more exoplanets, they encountered something unexpected. Many of the most common worlds in the galaxy do not exist anywhere in our own solar system. These planets are called super-Earths. The name sounds dramatic, but it does not necessarily mean they are better versions of Earth. A super-Earth is simply a rocky planet larger and more massive than our world, yet smaller than giant planets like Neptune. Some may be only slightly larger than Earth. Others could be several times more massive. And somewhere among these enormous rocky worlds may exist some of the most promising candidates for breathable environments in the galaxy. At first glance, a larger Earth sounds appealing. More land, more atmosphere, perhaps larger oceans and stronger protection from radiation. But the reality of these planets may feel deeply unfamiliar to human beings. Gravity is one of the first differences people would notice. On a super-Earth with significantly greater mass, gravity could become much stronger than on Earth. Walking might feel exhausting. Every movement would require more effort. Human muscles and bones evolved specifically under Earth's gravity. Even a moderate increase could make daily life difficult over long periods. Imagine standing on such a world beneath a thick atmosphere. Your body feels heavy. Lifting your arms takes more effort than expected. Running becomes tiring almost immediately. Rain falls faster. Waves crash harder against coastlines. Mountains may grow shorter because stronger gravity pulls landscapes downward over time. Yet stronger gravity also offers advantages. It helps planets retain atmospheres more effectively. Lighter gases escape into space less easily. A super-Earth may maintain dense breathable air for billions of years even if exposed to strong stellar winds. Some scientists think certain super-Earths could possess atmospheres thicker than Earth's, creating warmer and more stable climates. Clouds might stretch across enormous skies. Oceans may cover much of the surface. Weather systems could move slowly through deep air under powerful gravity. Then there are ocean planets. These hypothetical worlds may contain vast global oceans, covering nearly the entire surface with little or no exposed land. Some may hold oceans hundreds of kilometers deep, far deeper than anything on Earth. Beneath the water, pressure could become so intense that strange forms of ice might form even in warm temperatures, creating frozen layers deep below the sea. Imagine arriving at such a planet. From orbit, the world appears blue almost everywhere. Clouds drift endlessly across the atmosphere, while sunlight reflects from oceans stretching beyond every horizon. No continents break the surface. No mountains rise above the waves. Only water, sky, and weather circling the planet endlessly. The emotional feeling of such a place would be extraordinary. Human civilization evolved around land, coastlines, valleys, and rivers. Entire cultures formed through relationships with mountains and forests. An ocean world would feel beautiful, but deeply unfamiliar, almost dreamlike. Life there, if it exists, may evolve entirely within water. Scientists speculate that ocean planets could support enormous marine ecosystems beneath thick atmospheres. Currents might move heat around the planet efficiently, creating stable climates. Floating biological structures, drifting organisms, or vast underwater ecosystems may develop over millions of years. Still, ocean worlds also present challenges. Without exposed rock and land, certain geological cycles important for climate regulation may function differently. Earth's long-term stability partly depends on interactions between oceans, continents, volcanic activity, and the atmosphere. A completely water-covered world may behave in ways scientists do not yet fully understand. Some super-Earths may also possess atmospheres too thick for human survival. Dense air, rich in greenhouse gases, could create crushing pressure and extreme temperatures. Others might develop permanent global storms or oceans so deep that sunlight barely penetrates the upper layers. The more astronomers discover, the clearer one truth becomes. Planets can vary enormously, even when they appear roughly Earth-like from a distance. And yet many of these worlds remain tantalizingly close to habitability. Some super-Earths orbit within stable habitable zones around calm stars. Researchers analyze their atmospheres carefully, searching for water vapor, oxygen, and other possible signs of life. Every new telescope improves humanity's ability to study these distant worlds in greater detail. One fascinating possibility involves planets slightly larger than Earth, but still comfortable enough for human biology. Such worlds may possess somewhat thicker atmospheres, broader oceans, and perhaps richer ecosystems than our own planet. Forests there could grow enormous under denser air. Flying creatures might become larger because thicker atmospheres provide greater lift. The skies themselves may appear different too. On a planet with a denser atmosphere, sunlight scatters differently. The horizon might glow more softly. Clouds may tower higher into the sky. Sunsets could linger longer as light filters through thicker layers of air. Distant mountains may appear hazier because of atmospheric density. Even sound behaves differently depending on atmospheric conditions. Human voices might carry farther through denser air. Thunder could sound deeper and more powerful. Wind moving through alien forests may produce unfamiliar tones unlike anything heard on Earth. These details matter because breathable planets are not simply scientific objects. They are environments, entire living worlds with weather, landscapes, gravity, oceans, smells, sounds, and rhythms shaped over billions of years. For future human explorers, stepping onto a super-Earth may feel both exciting and unsettling. The air may be breathable, yet everything else slightly wrong. Gravity presses harder against the body. The horizon curves differently. Plants move in unfamiliar patterns beneath strange sunlight. Perhaps this is what humanity will eventually discover again and again across the galaxy. Not perfect copies of Earth, but worlds close enough to breathe while still remaining undeniably alien. And maybe that is enough, because the dream has never truly been about finding another Earth exactly. It is about discovering whether life and breathable skies exist elsewhere at all. Tonight, while Earth's oceans rise and fall beneath the moon, Countless super-Earths and ocean worlds continue orbiting distant stars across the galaxy. Some may be wrapped in endless clouds above deep planetary seas. Some may possess thick atmospheres glowing beneath red suns. And somewhere among those distant worlds, winds may already be moving softly through breathable air no human has ever touched. Every breath humans take is connected to plants, forests, grasslands, algae drifting through oceans, tiny mosses clinging to rocks. All of them quietly reshape Earth's atmosphere every day. Plants absorb carbon dioxide, release oxygen, stabilize soil, influence rainfall, and help regulate climate itself. Without them, the air humans breathe would slowly disappear. So when scientists imagine humans living on another planet, one question always returns. Can plants grow there? At first the answer seems obvious. Bring seeds, water them, provide sunlight, and plants will grow. But the reality is far more delicate. Plants evolved alongside Earth over hundreds of millions of years. They adapted to our gravity, atmosphere, soil chemistry, magnetic field, seasons, rainfall, and sunlight. Even the color of sunlight reaching Earth shaped the biology of leaves. Another planet changes all of those conditions. The first challenge is light. Plants on Earth use photosynthesis to convert sunlight into energy. Chlorophyll absorbs mostly red and blue wavelengths while reflecting green light, which is why forests appear green to human eyes. But stars across the galaxy produce different types of light. Around a red dwarf star, sunlight may appear dimmer and redder. Plants evolving there might develop completely different pigments optimized for available light. Some scientists imagine black plants on red dwarf planets because black surfaces absorb light efficiently. Alien forests beneath crimson skies might appear dark as shadow, quietly gathering every possible fragment of energy from their faint sun. Other worlds may receive unstable sunlight because of violent stellar flares or changing atmospheric conditions. Some planets may experience endless daylight on one side and permanent darkness on the other. Plants, there could evolve strange cycles unlike anything on Earth. Gravity also matters more than people realize. On low-gravity worlds like Mars, plants may grow taller and differently because less force pulls against their structures. Water movement inside stems changes under altered gravity. Roots behave differently. Pollen spreads differently through thinner atmospheres. Experiments aboard space stations have shown that plants can survive in microgravity, but they do not behave exactly as they do on Earth. Roots sometimes struggle to determine direction. Water forms unusual floating shapes around them. Even simple growth becomes more complicated outside Earth's environment. Then comes soil. Many people casually imagine Martian farms filled with crops beneath glass domes, but Martian soil is not ordinary dirt. It contains chemicals called perchlorates that may be harmful to humans and plants in large amounts. The soil also lacks the living ecosystem found on Earth. Healthy Earth soil is filled with bacteria, fungi, insects, decomposing organic matter, and complex nutrient cycles built over immense periods of time. Earth's forests are not simply collections of trees growing independently. Underground fungal networks connect roots together in astonishing ways. Nutrients move between plants through hidden biological systems beneath the soil. Entire ecosystems cooperate silently underground. On another planet, humanity may need to rebuild these systems almost from the beginning. Water presents another challenge. Plants require stable liquid water, yet many potentially habitable worlds may experience extreme climates. Some planets may possess long droughts. Others may endure freezing temperatures, violent storms, or acidic rain. Even if humans construct controlled habitats, maintaining agriculture on another world would demand constant energy and careful environmental management. Still, scientists remain optimistic because plants are remarkably adaptable. Certain species already survive in extreme environments on Earth. Mosses grow in Antarctica. Tiny plants emerge from cracks in volcanic rock. Some seeds remain dormant for years before suddenly blooming when conditions improve. Life repeatedly demonstrates an astonishing ability to adapt. Experiments using simulated Martian and lunar soil have shown that some plants can grow surprisingly well when nutrients and water are added carefully. Potatoes, lettuce, wheat, and other crops have already been tested in controlled environments designed to imitate extraterrestrial conditions. Future settlements on Mars or other worlds will almost certainly depend on indoor farming systems. Imagine walking through a greenhouse beneath the surface of Mars. Outside stretches cold red desert beneath dusty skies. But inside the habitat, warm air smells faintly of soil and growing leaves. Artificial lights glow softly above rows of crops. Water recycles through pipes and filtration systems. Tiny droplets cling to green leaves while machines quietly regulate temperature and oxygen. In such places, plants would become more than food. They would become emotional anchors to Earth. Human beings evolved surrounded by living ecosystems. Forest sounds calm the mind. The smell of grass after rain creates comfort. Green spaces reduce stress and improve psychological health. Long-term survival on another planet may depend not only on oxygen and calories, but on preserving small pieces of Earth's living environment. Astronauts already describe emotional reactions to seeing plants grow in space. Even small leaves floating inside orbiting stations create feelings of connection and normality. On distant planets, gardens may become some of the most precious spaces humans ever build. Scientists are also studying whether plants themselves could help transform alien environments over time. This idea forms part of terraforming, the concept of gradually altering another planet to make it more Earth-like. In theory, microorganisms and hardy plants might eventually help produce oxygen, enrich soil, and stabilize climates on suitable worlds. Such transformations would require enormous timescales and advanced technology. But the possibility continues to fascinate researchers and dreamers alike. Yet even if plants grow successfully elsewhere, alien ecosystems may still remain profoundly different from Earth's. Imagine forests beneath thick purple skies where gravity is stronger and rain falls more slowly through dense air. Imagine giant dark leaves spreading beneath a dim red sun. Imagine vines climbing across rocky coastlines, while unfamiliar winds move through strange branches. And somewhere in those forests, perhaps humans one day walk without helmets, breathing air partially created by plants carried from Earth. That moment would hold extraordinary meaning. The first tree growing naturally on another world would represent more than biology. It would represent continuity, a living connection between Earth and the wider universe. Proof that life from one planet can spread gently into the darkness beyond its birthplace. Tonight, while forests across Earth release oxygen silently into the atmosphere, scientists continue studying how plants behave beyond our world. Tiny experiments inside laboratories and spacecraft may someday shape entire future ecosystems beneath alien skies. And somewhere among the stars, there may already exist forests unlike anything humanity has ever imagined, moving quietly in winds from another world, while producing air for forms of life still unknown to Earth.
you.